You can see here a picture of some green crystal that you made in the lab, and it's a hydrate. There are water of crystallization embedded within it. Also below it is copper 2 sulfate, which has some waters of crystallization. By heating it, we can drive off the water to create the anhydrous compound. You're going to do that with the green crystal to try to figure out how much water is in the formula when you figure out the empirical formula. Because the mathematics of figuring out the amount of waters is similar to figuring out the empirical formula of any compound, we're going to take a look at the process and we're going to use a parallel mathematical process. So here is an example of a calcium sulfate that has a certain amount of water. We don't know what X is. We know that we have 67.5 grams of the mixture of the crystal, and we heat it until all the water is driven off, and then we have 53.4 grams. So we want to find the formula of the hydrate and its formula mass. So we're going to set it up as a little equation, and our knowns are the 67.5 grams of calcium sulfate dot some H2O, 53.4 grams of calcium sulfate, and the law of conservation of matter tells us that there must be 14.1 grams of water. Now we're going to set it up the same way we do an empirical formulas problem, but instead of using the elements, we're going to use compounds. So I have my 53.4 grams of calcium sulfate, and I find how many moles that is. That's the molar mass of anhydrous calcium sulfate, CaSO4. I know I have 14.1 grams of water, and I'm going to figure out how many moles that is. So now I know there were, in my original calcium sulfate .xH2O, 0.3922 moles of calcium sulfate and 0.7825 moles of water. I'm going to divide by the smallest, as I do with empirical formulas. And by dividing by the smallest, I end up with a 1:2 ratio, which means my formula is calcium sulfate dot 2 H2O. And now all I need to do to find the formula mass is the 40.01 calcium and the 32.06 sulfur and the 4 times 16 oxygen and the 2 times 18.02 water. You can do the hydrogens and the oxygens separately if you want. But we end up with a formula mass of 172.11 grams. Only possible if we know the amount of water, and that's critical when we're trying to figure out how much we need to weigh on a balance. If I know I need a certain amount of moles of calcium sulfate, I have to take into account the fact that 172.11 is the molar mass of what I'm weighing off the shelf, not 136.15. So in summary, we treated it just like an empirical formulas problem, but instead we took the molar mass of the anhydrous and the molar mass of water, convert both to moles, divide by the smaller, and end up with a formula. Now it's your turn to try the problem. Pause the video and try to figure out the formula for this potassium aluminum sulfate hydrate by figuring out what is X. When you're ready, start the video again. Okay, I'm assuming you've finished the problem by now. So let's take a look at the answer. There were 5.459 grams of the hydrate, and after we heated it, 2.583 grams of the solid remained, which must have meant, through subtraction and the law of conservation of matter, 2.876 grams of water evaporated away. If I convert both of those numbers in the products to moles, I end up with 0.01 mole of the anhydrous potassium aluminum sulfate and 0.1596 moles of water. My potassium aluminum sulfate is the smaller number, so divide both by 0.01, and I end up with 16 waters for every anhydrous potassium aluminum sulfate, which means X is 16. There are several problems like this in your homework, so give them a try. Good luck!